Alright, you guys, I'm going to try to help you through these notes really quick. As you can see, today we're going to be doing a new transformation. It's called a reflection. And I am hoping that you can figure out how to, that's why I showed you last Thursday or Friday, depending on the last time we were in class together, how to do an absolute value function. So I believe you'll find this right underneath the exponent. You have to do the input and then exponent, and you should get this radical function. And what this is going to be called is going to be our parent function. And if you could put that into your y equals under y1 and use a standard window, that's negative 10, 10, 1, negative 10, 10, 1, then we can get started. If you want to pause the video here for a bit until everyone's there, I will wait for you. Now, if you could go back to y2 and input the same function, but this time put a negative in front of the function. Now, if you understand that your x being your input and the actual function, what happens within this function is that a radical, the negative in this situation takes place after the function. And hopefully you can see that, and I'm going to draw a really quick graph, and you'll have to, I apologize that it's going to be a little bit messy here, but the original function is going to look something like this, and that would be the y equals the square root of x function. Alright, but when you graph y equals the opposite of the square root of x, and I'm going to go ahead and make this a little darker, maybe choose a better pen, and let's see if that helps out a little bit. Yeah, a little bit. Alright, opposite the square root of x, we're going to get a graph that does something. So what you've done is you've now changed your output. You're still plugging in x, so x is going to give you a lot. It would normally give you this function right here. But we're saying take every output and take its opposite. So if your input was 1 and you got, and then I'm just going to draw some example dots that you'd get. All right, these would normally be the outputs as seen over here. Well, the opposite of them would bring you down. All right, you're really reflecting over the x-axis, and now you've got a graph that is going to look like this bottom graph right here. Now, if you want to pause and talk about it for a bit on this video, please do so now. Make sure everybody understands. Maybe discuss with your neighbor. Okay, I'm going to start again, and here we go. This right here says y equals, and you notice what I've done, and a lot of times you're going to see the negative in the numerator along with the x, but I'm going to kind of keep it pretty obvious how we're changing the b function, which we'll talk about pretty soon. And we'd like you to graph that. And if you could maybe just replace the y sub 2 with this new y sub 2, right? And again, I'm going to go ahead and put our parent function here. If I had y equals radical x right there, my parent function would be this again. So let's look what we're doing with this function now. We're taking y equals radical, but now instead of taking the opposite of our output, we're actually changing our input down here. Alright, so what that does is it has an effect on things right here. Alright, normally this would be our graph right here. This would be our graph. However, now what we've done is we've taken our input before we take the square root, and we're taking the opposite of the x values. So now you're going to see a graph that looks like this. Alright, so our new graph is going to do like this, which is a reflection over not the x-axis, but the y-axis. So if I change my input, I reflect over the y. If I change my output, I reflect over the x. Okay. I'm going to come down here. Hopefully you guys are with me. And if not, feel free to rewind and go back through this and ask questions and see who can discuss and understand this. We're going to go down this and consider this formula which depicts all the transformations for the parent graph. And you've seen this with me a few times. It's y equals a, and then I really should put this in parentheses, but it doesn't need it. X minus h and over b, and I'm going to change something right here. Do you see this radical? This radical should stop right about this. This k should not be underneath the radical sign. And I'll try to change that on your papers, but I'm not gonna retape this, so you're gonna see a mistake right here on this, but hopefully I'll get it before I print it off. I'll change it for you guys. Now we want to talk about how the changes in A, which is what we did up top, alright, affect the graph, and we can see it right here. And down here, I'd like you to write about how the changes in B. Now, I don't want to come up with this for you. I want you to discuss and figure it out yourself. If you could pause it right now and then see what everybody has as an answer. I'm going to have one final challenge for you. Alright. Hopefully you have a very nice description of how they reflect over different axes right here. I would like you to think about what this would look like. What if I have y equals the opposite of this, and then the opposite here? What would that look like? Alright, go ahead and give it a pause, and then I'll come back and show you the answer. I hope this is working out okay. Hopefully you've unpaused and can hear my voice again. So let's do this one at a time. If I was going to substitute, and here's the parent graph. So if I was just going to follow the order of operations, this guy right here would have me take the opposite of my inputs. So originally I would go right here. And then after it was squared, right, I would take the opposite of my outputs, and now it would reflect again, making this right here your final graph. Of course, as we input h and k, now we're sliding these graphs around, but this is the basics right here. So I hope you enjoy your new transformation, and let's get to the homework.